When one thinks of energy, we often refer to energy required to complete a task or the painstaking experience we had in physics. Overall, when you think of putting energy into something, the effects are normally positive. However, in terms of radiation, any source of energy transfer is potentially harmful to organisms such as humans and animals alike. This is why there is high concern about the ozone layer of the Earth's upper atmosphere and the high energy radiation from the sun. There are also radioactive elements that pose potential harm, although the effects are normally subtle. The subtleness of these radioactive elements is due to the small quantity of energy that is deposited in tissue per event. There are two types of radiation damage that can impact organisms. These are known as somatic or genetic damage. Somatic damage is damage to the organism itself. Think of getting hit by a car. The victim of this impact is immediately affected. However, if there are smaller doses of somatic damage, the resulting cancer may appear later on in life. Genetic damage is often the next generation's problem, for malfunctions in the offspring are most commonly seen. Not all effects of radiation are the same. The biological effects that occur all depend on the energy of the radiation, the penetrating ability of the radiation, the chemical properties of the radiation source, and the ionizability of the radiation. First, the higher the energy content of the radiation, the greater the damage. These doses of radiation can be measured through rads, in which 1 rad equals 10 to the negative second joules of energy deposited per kilogram of tissue. Not all radiation has the same skill set, which is apparent in their penetrating ability. Some rays and particles are highly penetrating while some are stopped by the skin. The ionizing ability also greatly varies. Those rays and particles that penetrate deeply use only occasional ionization, while those that do not penetrate as deeply are very effective in causing ionization. This creates a long trail of damage. Due to the bipolarness of particles and rays produced by radioactive decay, the energy dose of the radiation and its effectiveness in causing damage must be taken into account. This is represented by the REM, which is defined as the number of REMs equals the number of rads times RBE. The RBE shows the relative effectiveness of the radiation in causing damage. Surprisingly, natural resources contribute twice as much as human activities to the total radiation exposure of an individual. We all hear about the nuclear industry and the potential for radiation hazards. However, the nuclear industry contributes only a little to the total radiation exposure in a person's life. The potential for hazards arises mainly from accidents that allow for the release of radioactive materials and improper disposal of the products in spent fuel elements. I know what you're thinking. Just dispose radioactive waste in the proper manner. The problem is that there has been no disposable method that is totally accepted. Some people believe incorporating waste into ceramic blocks and burying these blocks in geologically stable formations is the way to go. However, because of uncertainty, nuclear waste continues to accumulate in storage facilities. Two models of radiation damage known as the linear model and the threshold model have been proposed. The linear model states that damage from radiation is proportional to the dose. This means that any exposure, even low levels, is dangerous. On the other hand, the threshold model states that there is no significant damage that occurs below a certain exposure, which is called the threshold exposure. Scientists have found little evidence to evaluate these models. Therefore, it is safest to assume that the linear model is correct and limit radiation exposure to a bare minimum. There are many medical applications of radiation. The most well-known example of this is X-rays. In fact, the broad use of X-rays is known as radiology, and the areas of medicine that use radiation for treatment of diseases like cancer are typically called therapy. Nuclear imaging, CT scans, and other forms of medical imaging have allowed for the detection and diagnosis of diseases in their earliest stages. Many concerns have been expressed in regards to the mixing of medicine and radiation, but the overall contributions are positive and from a medical standpoint less risky than exploratory surgery.